All right. Hey, everyone, attention up here, please. Okay. We're going to take a look at 3.5 today. So 3.4 is a lab with algebra tiles. So it's kind of a pre-lab to this section. So we're going to do 3.4 and 3.5 kind of together. We will talk a little bit about algebra tiles. Again, I'm not bringing the algebra tiles in here. I'm going to show you some algebra tiles. If you really want to work with algebra tiles, if what you see here you really like and you want to work with algebra tiles, come talk to me. I can get you some, and you can work with some. We might have to just meet at noon and start off that process because I don't have any here today during this lesson. But algebra tiles are like a tactile, something you can feel and touch and move around on the table. It's a manipulative that we can use to understand this. So I'm going to show you what the algebra tiles look like, what they mean, and how we can work with polynomials that are in this form. So x squared plus, and the b is like a number, so some number times x, plus c is another number. So these are trinomials. Remember, a single term is a monomial, two terms in a polynomial is a binomial, and three terms is a trinomial. So trinomials that have an exponent of 2 here on one of the x's, super common in math. Very, very common, very important. Like, probably the most important type of polynomial that you will ever see in math ever, including calculus and university stuff. It's one of the most important ones, certainly in high school. So we need to know how to work with these. We need to know what they look like. We need to know what the graphs look like eventually. We need to know what roots and zeros are for equations that have this in them. We need to know how to factor them, how to get to them, how to break them down. We need to know everything we can know about this. It's called a quadratic, okay? And like I say, in grade 11 and 12, we will focus a lot on these. So this is very important to understand these things right here, okay? So this is again, trinomial. The big thing is that there is a 2 as an exponent on one of the x's, okay? It's a squared there. This is a degree 2 polynomial because of that 2 is the largest exponent that you see on any of the x's. And it has 3 terms. It's a trinomial, okay? Degree 2 trinomial. Now, there are degree 3, 4, 5, 6 trinomials as well. We're just going to deal with these types, okay? So let's back up a little bit and let's just think about this. If we have 2 binomials that contain positive terms only, and again, this is in your text on page, what is this? What page is this? Let me show it out. 160, 161, say? 159 is where 3.5 starts here. Okay, so this is on 160 really. So positive c value, we have a plus 5, we have a plus 3, okay? Now in this case, you can easily use algebra tiles to represent each binomial. Okay, now, when we use algebra tiles here, the c, okay, is like the long rectangle one, okay? And the 5 and the 3 consist of 3 little squares and 5 little squares, okay? So in algebra tiles, this c plus 5 is this one down here, okay? It's a long rectangle tile and 5 little squares lined up. And the c plus 3 is this one up here. It's a long rectangle one with 3 little squares, okay? Now what's the significance of that? Well, if we were to arrange these tiles, okay, in as dimensions, length and width, okay, what we would see is that we could form, with other algebra tiles, we could form a rectangle that fully kind of completes this rectangle with those dimensions. All right, that's kind of cool. So again, if we just focus on, this part right here, okay, this part right here, we see that this collection of algebra tiles, okay, has a height here, this dimension of c plus 1, 2, 3, 4, 5. This is c plus 5. Up top here, this dimension is c plus 3. Everybody see that? So if we were to multiply c plus 3 times c plus 5, that would be like multiplying length times width, and we would get the area of a rectangle, okay? So if one dimension times the other dimension, That would be the area of the corresponding rectangle. So let's see what the area actually is if we multiply those together. I'll zoom back out here a little bit. Okay, so the actual area, let me see if I can get both that in there. Ooh, close. The actual area is this big square, which in algebra tiles, this is a squared. That is 1c squared. Then we have 1, 2, 3, 4, 5, 6, 7, 8. We have 8 C's. And we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. We have 15 little constants there, little squares. So that algebra tiles, what they tell us is this, is that C plus 3, when multiplied with C plus 5, gives us C squared, or 1c squared, plus 8c plus 15. And I'm zoomed in still quite a bit. Okay? That's what algebra tiles tell us. And what we're going to look at today is how do we get from multiplying a binomial times a binomial to this trinomial state. Okay? Because when we multiply any binomial times another binomial, okay, most of the time, I shouldn't say whenever, but most of the time we're going to get a trinomial that looks like this with 3 terms. Okay, so that's a little bit about what 3.4 was about, arranging the tiles, and hey, can you make another type of rectangle? Okay, I'm going to make another rectangle here with, 4 of these squares, and I'm going to, make some other rectangles here, and I'm going to put this. Right, okay, so then you make a rectangle, and guess what? That rectangle is an area, and you have some binomial here and some binomial on the side, and this times this gives you this area. So we're just exploring that. I'm going to talk to you more about that, but more in algebra terms, okay? So without the tiles, if you had to multiply C plus 3 times C plus 5, I'm going to show you how to do that. And I think what's going on here? Insert space. Okay, don't worry about this example. I'm going to get to that in a second. Draw, insert space. There we go. Technology. I'll love it most of the time, whenever I don't hate it. Okay, so, all right, so C plus 3 times C plus 5. Okay, a binomial times a binomial. How many of you have done this before? Okay, a few hands. Do you remember me talking about the FOIL method the other day? And some of you are like, wait, what? What did you say? FOIL method? Have anybody talked to you about the FOIL method of multiplication before? Okay. Okay, some are nodding, some are thumbs up, some are like blanking. Okay. So I'm going to teach this to you now, the FOIL method. Okay, but I'm going to back up for 1 second. Okay. So let's say I want to do C alone times C plus 5. Okay, well, that's not too bad. What you do is you take the C and you distribute multiply. So you go C times the first C gives us C squared, right? C times C gives us C squared. You remember that from grade 9? All right. And then you distribute to the other terms in the next one, and that's a positive 5. So this is plus 5C, because C times 5 is 5C. So do you remember this? Multiplying by distribution? You seen that before? Yeah? Okay. Because if I make it even simpler, let's start with C times C. Okay, I multiply. That equals C squared. So if I add a 5, that means I have to keep multiplying. Okay. Now in this situation, C plus 3 times C plus 5, I basically have to do 2 levels of distribution. I have to distribute the first term here to both of these terms, and then I have to distribute the second term also to both of these terms in the second one. So there's a memory sort of mnemonic. There's something that helps you remember how to do this distribution, and it's called the FOIL method. So I'm going to start by FOIL, all capitals. I'm going to write them downward like this. And so the FOIL method helps us to remember how this distribution would work. I always start with the first term and I multiply it by the other first term. So the F stands for first terms. That's what you multiply first. First terms, f, first terms. So let's do that. I'm going to write c squared here because c times c is c squared. This is a c to the 1. This is a c to the 1. If you have the same base, you add the exponents, so it's c squared. All right? Oh, now this second bit of distribution goes the first one to the second one over here, and guess what? These are both the outside terms. So O is for outside terms. That's what you multiply next. So c times positive 5 is plus 5c. Now I've successfully distributed term 1 into both of the terms in the second one. Now I need to go to the next term, which is 3, and so the I stands for the inside terms. Very good. So now we'll go to inside terms. Positive 3 times c, and I just write that positive 3c, which turns into a plus 3c, right? See, the positive 3c really now behaves like a plus 3c. Okay, finally, I'm going to go with this 3. What color should I use? Yellow. This 3 times this 5, and those terms are the last terms. Very good, the last terms. We multiply the last terms, and 3 times 5 is 15. Notice we have a constant now. There's no variable in that one. Okay? So first terms times outside terms times inside terms times last terms. Okay? And you will see me draw kind of like arrows or lines connecting to above and then to below. That's the way I show it. So now, from yesterday or the last class, we worked on gathering like terms, right? And so c squared does not have another like term anywhere in there. So I just write c squared. There's 2 c terms. So I combine these because they are like terms. What is 5 carats plus 3 carats? 8 carats. They're like terms. And the 15 does not have another constant to add, so I will just write this down. Now, do you see how that gets us the exact same polynomial as the algebra tiles that we saw there? 1c squared plus 8 c's plus 15 little constants. Everybody see that? So the FOIL method is going to help us multiply binomials times binomials. Okay. All right. Let's do another example. Let's expand and simplify. And again, we are going to focus on the FOIL method. Cool. All right, so first terms, x times x. What does that give us? X squared. Very good, x squared. Outside terms, so that's x times positive 2. What do we get when we multiply those together? 2x. 2x. Now that's a positive 2x, so I will write the positive 2x. We are going to have a negative involved here. You see how x minus 4? So the inside terms, please consider the sign as well as the number. You have to consider that when you multiply. Negative 4 times positive x is negative 4x. We write that as a minus 4x. You see, that's the one little difference now. And then the last terms, negative 4 times positive 2 is negative 8. Okay? Very good. Now we've expanded using the FOIL method, and I'm going to gather like terms now. X squared. Ooh, this is a tough one. What's 2x minus 4x's? Negative or minus 2x, right? Minus 8. And that is your answer. Okay? Any questions about that? Okay, do one on your own, and here is the one I want you to do on your own. Are you ready? Yeah. A minus 1 times a minus 5. Okay, take a minute and do that one on your own. Okay, so this one's a bit tricky because it's got 2 negatives in here, but again, not tricky for you guys, because you know what happens when a positive and a negative get multiplied? That's always a negative, right? If they're different, it's always a negative as a result. If they're the same, it's always a positive. So a positive times a positive is positive value. A negative times a negative also is positive. So let's do this. FOIL method. A times A is A squared. A times negative 5 is minus 5a, or negative 5a, which is minus 5a. This is a minus 1a, or I'll just put a there. You don't have to put the coefficient of 1. You can, but you don't have to. In the answer, you shouldn't have it. But while you're working, if you want to do this, totally fine. And then negative 1 times negative 5 is plus 5. Right on. So now I gather my like terms, and look what happens. I have a squared. These two are together. Negative 6a, or minus 6a plus 5. So the result is a squared minus 6a plus 5. Who got that? Put up your hand nice and loud and proud. Awesome. Okay. All right. So again, all we're doing is distributing twice. The first term distributes in. The second term distributes in. Gather all your like terms. And there you go. A quick note. We are going to write this in, this is a fancy term, you ready? Descending order of the variable, which means that we're always going to try and write the largest exponent on the variable, that term first, and then the next largest exponent on the variable, in this case would be 1, that term next, and then the next largest. And you say, well, there's no variable. Yeah, actually, guess what? This is a to the 0 technically. So I've got a squared, a to the 1, and because this is a constant, that technically could be viewed as a to the 0. So that's why the constant goes last. Now you do not write a to the 0, just like in the end you wouldn't write a 1 as a coefficient, but that is in descending order of the variable, and technically this is an a term as well, just the exponent is 0. Make sense? No? So a to the 0 is 1. Any number to any variable to the 0, anything to the 0 is 1. Anything to the power of 0 is 1. So if this is like 5 times 1, you could write that as a to the 0. All right, don't worry about it if it goes over your head just a little bit, that's okay. All I'm saying is that the constant goes last, the largest exponent 1 goes first, and then you arrange in between. Sorry, I try and give you enough information to help you survive, a little bit of information to urge you on to something beyond yourself, and I try not to lose you or drown you in the process. Okay, let's do this one. This one looks tantalizingly terrifying. Shall we do a tantalizingly terrifying example? Yay! Oh no, what happens if the variable is in the second position in the binomial? That's totally going to mess things up for us, right? No, not right at all. It's going to be,
that was easy.
That's what we're going to say when we're done this. You guys don't have an easy button?
That was easy.
I don't know where I got this from. Staples, maybe. I might have stole it. I don't know. Back before I was saved. I don't know. No, I don't know. I got this. Yeah, I got this from Staples. It says Staples on it. So, yes, I bought it.
That was easy.
I purchased it legally. Okay. All right. So I wonder, do you think that FOIL method would apply here, or do we need something new because the terms are switched around a little bit? What do you think? You think we can still do FOIL? Okay, well, let's try it and see what happens. Hint, spoiler alert, yes, we can still do FOIL. 8 times 3, guess what? We're just going to have our constant written first. Big, hairy deal. No one cares. What's 8 times 3? Anybody remember? 3 groups of 8, that's 20 what? 4. Awesome. So that's F for FOIL first. Outside terms are 8 times negative b. What's that? Negative 8b, or it turns into a minus when I list it here. Very good. Inside negative b times 3 is negative 3b. And then negative b times negative b is positive b squared. So that's what I write like that. Excelente. So common terms are the b terms. Got bananas there, right? So we got 24 minus 11 bananas. You owe me 11 bananas here for some reason. Plus b squared. Now, you could leave it like this technically, but in big kid math grades, we want to generally write things in descending order of the variable. So, everyone pay attention? No. Everyone pay attention now? 3, 2, 1. Hello. So when you, very carefully, when you rearrange terms that are added or subtracted, you can totally just rearrange them, but you have to keep the sign that's attached to them. For example, if I owe you 11 bananas here, and I want to tell you that after later or earlier in the process, I can move those around, but you still owe me 11 bananas, whether I tell you that first or whether I tell you that after some other information. Now, if I owe you 2b banana squareds, don't know what that is, probably some treat from DQ, I'm sure. And if I want to tell you that first, I can just say, hey, I owe you 2b squareds. Now, we don't write the plus sign when we list the term at the beginning. But that's still a positive b squared. You see that? I'm just going to move that to the front of the list of things I'm going to tell you. I'm going to keep this in the middle, so by the way, you still owe me 11 bananas. And then I still have $24 in my pocket, so now I turn that into a plus 24. Because this is a positive 24, really. So, you know what, if I want to change it around, it's just like I'm telling you the story, but I'm not going to start with the fact that I have $24 in my pocket. I'm going to tell you first that you owe me a banana squared. Or that I have a positive banana squared and that you owe me 11 bananas and that I have 24 bucks in my pocket. So you can rearrange things around, just keep the signs that they have wherever they go with the numbers. Capiche? Anybody want a banana split right now? I do. Oh. What's your favorite royal treat at DQ? Timeout. This is timeout. What's your favorite royal treat? Like banana split. What's that? The peanut butter parfait. What else they got there? What else is there? Blizzard. I don't think that's a royal treat. But what are there any other royal treats?
Oh, they are. There's Oreo. Did you say Oreo?
Or I don't know. Fudge explosion something, or I don't know. What's your favorite? Shout it out. Peanut butter parfait. There we go. Okay, that's it. That's the best. Choco. Okay. Here we go. Okay, you ready? This is where it gets real, everyone. This is where it gets real. Are you ready? We're entering the twilight zone. Yes, there's more. Expanding binomials is the easy part. Now, we need to work backwards.
Oh, so from that answer, we have to find.
From that answer, yes, we have to find. Come on. We have to find. Okay, so we're given these answers now, and now I gotta go backwards. I know. How should I do this? Oh, forget that. X squared minus 2x minus 8. Nope, let's do an easier one. It's an easier one. Yeah, here we go. Okay. C squared plus 8c plus 8. Let's go back to the very first one. C squared plus 8c plus 15. Okay? So now I'm going to factor this puppy. Factor. Okay? Whew. So, all we're doing is going backwards. So, we have to remember what we did to get there, and then we can kind of work through going backwards. Now, there's different ways of doing this. And there's two main ways of doing this. One involves more like intuition. That means you kind of do mental math, a little bit of mental math to work backwards in this process. Another method is factoring. It's called by decomposition. Some people love decomposition method because it's a little more prescriptive. That means it's like, here's the step 1, here's step 2, here's step 3, here's step 4, but it takes a little bit more time. But I think I'm going to get to decomposition a bit later. I'm going to try and work with some easy ones to help you do the intuition, okay? We're going to work on our mental math intuition method with some easy ones. Okay. Now, we look at this, and you say to yourself, I have a trinomial, I have a squared variable term, I have a regular to the power of 1 variable term, and I have a constant. Whenever you see that, you think, probably this is going to be factorable. I can factor this into 2 binomials. And that's what most of these ones are going to be. I will need you to get practice with these ones. So you'll be able to split this trinomial into 2 binomials. So this is literally what I'd like you to do. Make the brackets, leave them empty. Okay? So you see this and you see, hey, I have a 1c squared, I have a whatever c term, and I have a constant. This is probably going to be able to be factored into two binomials, because to get something like this, I would normally do the FOIL method between multiplication of two binomials. Okay, so now again, let's think backwards. This c squared term came from multiplying what times what? The first terms were c and c. So guess what? That's your first step. What gives us c squared? Easy. That's c times c. And so those are going to be your first terms from the FOIL method, remember? Okay. Now, the middle parts get a little bit tricky, but the end part, the last term, that's easy. That's easy. So what two numbers could possibly multiply to positive 15? Now, there may be more than one pair, right? In this case, there certainly is. We know about factors now. 1 times 15 works, or 3 times 5 works. Are there any other options? Nope. Okay. So I don't know. So here's the tricky part. With intuition, here's where the mental math comes in. You know that there's some options, and you say, I wonder if plus 15 and plus 1 would work. Well, that gives me 15, but now you have to go the step further and consider this middle term. And that's where the FOIL method and mental math is going to come in handy, okay? So you got to do 2 calculations, technically 3, in your mind for this to work. And this is what you're going to do. C times 1 and 15 times c. That's c plus 15c, right? Now, does this give you 8c? Nope, that gives you 16c. So guess what? This combination of last terms to make 15 is wrong, because it does not match up with the middle term. Everything has to match up. So here, now you go, okay, I know what else gives me positive 15. That's easy. Negative 15 and negative 1. Because that's true, isn't it? Negative 15 times negative 1 gives you positive 15. And now, in this method, a little mental math with your FOIL method, let's go c times negative 1 and negative 15 times c. Does that give me positive 8c when I combine these two? No. So again, this combination of numbers is incorrect. Now, the more practice you get with this, the quicker it'll get. And you'll see in your mind, and this is what I want you to focus on, 15 comes from a possibility of 1 and 15, or from negative 1 and negative 15. We ruled both of those out already. It also comes from 3 and 5, and negative 3 and negative 5. So in this intuition method, you want to, in your mind or on paper like this, write down all the factors of 15, because you know that this term and this term have to multiply to 15. So I'm going to write down my possible factors, and then you're going to see which set of these factors adds up to your middle term. Plus 3 and plus 5 add up to plus 8. So this is the magic pair. You're going to forget about the other ones. So we have plus 3 and plus 5. In either order, you could write your plus 5 one first, it doesn't matter. But now, again, you do a full FOIL and see if this ends up to be your original question. C squared plus 5 plus 3c is plus 8c plus 15. Yes, that matches with my original question. Therefore, I have factored this correctly. The 8c came from 5c plus 3c. 5c plus 3c. Okay? That's just example number 1. Okay? We're gonna do lots of examples. This is gonna be okay. I promise. Okay, let's go back to another one. Should we mess around with the negatives yet? I'm not gonna mess around with the negatives yet. No, we need some more practice. So let's say, I'm gonna make one up here. X squared plus 7x plus 10. There we go. Now this is a trinomial. It's got 3 terms. It's got an x squared term and an x term and a constant. Beautiful. probably going to be able to be factored into two binomials, and we're going to check to make sure that's true. So again, do we have any idea what the first terms might be looking at this right here? X and X. That's the easy part, right? Now again, these two spots, okay, these two spots, we have to look at this term. It's a positive 10. And so what you want to do is you want to list the factors of positive 10. 1, 10. Negative 1, negative 10. 2, 5. Negative 2, negative 5. And are you going to have to do this every time when you get good at this? No, you're not going to have to. But right now, I'm trying to help you to see what your mind will be thinking of later. And so you look at these combinations. Okay, 1 plus 10, does that give me 7? Nope. Negative 1 and negative 10, when I add those together, that gives me negative 11. That's not right. Okay, positive 11, negative 11. 2 plus 5 gives me positive 7. Oh! Whoa! Look at this. Positive 2 and positive 5 gives me positive 10 when I multiply. And plus 2 plus 5 when added gives me plus 7. I've found my winner. So literally what you do is you put plus 2 here and plus 5 there, and you factored it. It's done. A quick FOIL check looks like this. X times x is x squared. Outside terms, that's plus 5x. Inside terms, plus 7x. And last terms, plus 10. Oops, I'm ahead of myself. Plus 2x. X squared plus 7x plus 10. That checks out with our original question. So we factored it correctly. This is your answer. Okay? So, when factoring, let's jot down a little brief note on this, okay? When factoring trinomials, and I'm going to put this in brackets because this is going to be important next section, where a equals 1. And in our form, in the form ax, oh gosh, can I do this? Ax squared, dope, plus bx plus c, and that a should be a little a, but it auto-corrected on me. Okay, so in this form, ax squared plus bx plus c, where a is 1, that's going to be important. That's all the examples we're doing though. Find factors of c, that's the c constant, that add to b. I'm going to make this a little bit bigger so you can see it in the back. And if you can ingest this and get this, this is going to be easy for you. Okay? So again, where a is 1, if we have a number like 2 or 3 or 10 or negative 5, that's a different story, and we're going to get to that. But in the easy ones that we're focusing on today, where this is 1, all you need to do is find the factors of c that add up to b. And those will be the missing numbers in your two binomials. Okay? Are you ready for some more fun examples? No? Can I, what? Can I scroll up? I can scroll up. Do I want to scroll up? Why do I want to scroll up? I'm going to give you another example. No, I'll give you another example here. If you haven't finished that last one, I'll come back to it in a bit. Let's keep moving on here. Okay. Again, this is going to be an easy one, another easy one, and then I'll gradually make it more and more difficult, okay? X squared plus 13x plus 30. No. No. Yes. Okay. So this is a trinomial. A is 1. Okay, no problem. I want to focus on 30 and I want to think of all the factors of 30. Oh gosh, there's a lot of them. Do I have to list them all? I just have to list the ones that might add up to 13. That's what I'm looking for. So let's see. I can't think of it right away, so I'll just start listing them. 2 and 15, 3 and 10, 5 and 6, and then there's all the negatives. Well, this is a positive, so I'm going to focus on the positive ones first. So are there any of these pairs of factors that add up to positive 13? 3 and 10. Look at that. 3 and 10 multiplies to 30. Ding, 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 ding. 3 and 10 adds to 13. Ding, 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 ding. We have a winner, folks. Okay, so the other parts are easy, like 2 binomials, x squared, that's easy, x times x. The numbers that I complete these binomials are going to be what? Plus 3, plus 10. Now, I'm going to check this. We have to check this. You always have to check. So check is going to look like this, really easy. X times x is x squared. FOIL method outside x times 10 is plus 10x. 3 times x is plus 3x. 3 times 10 is plus 30. X squared, add like terms, plus 13x plus 30. Okay, now I spent a little bit more time on factoring than the FOIL method because this sort of, that's what the main point is in this lesson, so that's what we got to get to. If you are still unsure about the FOIL method, multiplying out, you'll need to practice that. Either come talk to me, watch some videos on the FOIL method, just get some more practice. But the factoring is where we want to go to, okay? All right. Okay. On a scale of 0 to 5, 5 being, I get this, I could teach this to someone else. 0 being, sorry, what did you say the last 45 minutes you were talking? I didn't hear any of it. Where are we? Wow, some of you guys are like more than 5. Okay, cool. Wow, so smart. 0. Yeah, right. Yeah, right. Huh. Okay, 6s. All right, 6s over there. Are you ready for this? Are you ready for this? W squared. That's right, I said W. Plus 6W minus 27.
Okay.
Now, do not get into the fetal position, suck your thumb, and start crying. This is not that bad.
You can do this now.
I know, this could be the toughest day of your life. I get it. But we're going to get through this together. Okay. Now, my teacher told me that I should probably make these brackets to try and find out if I can factor this into 2 binomials because we have a 1w squared, we have a w, we have a constant. My teacher also told me that I should list, are you ready for this? The factors of, paying attention? Paying attention? Negative 27. So that means I need a positive and a negative. So 27, I've been pretty friendly to you. There's only some really obvious factors, right? Negative 1, positive 27. Positive 1, negative 27. What other ones? 3 and negative 9. Negative 3, positive 9. Anything else?
Oh, is it?
Now, from that list, do you see any combinations? Obviously, these all multiply to negative 27. Any of these combinations also add up to positive 6? No, no, no. Bing, 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 bing. Does that add up to negative positive 6?
Yes.
Oh, number line. Where's my friendly number line? There's 0. Here's negative 3. If I go up 1, 2, 3, 4, 5, 6, 7, 8, 9, boom, I end at positive 6. Math does make sense. All right, easy peasy. Lemon squeezy. W, W. Easy. What do I put here? minus 3 plus 9.
Yes.
I'm going to check that. Should I check it? Yeah, I should check that. W squared plus 9w minus 3w minus 27. W squared plus 6w minus 27. That is exactly what I started with. There is your answer, my young Padawans.
Are we circling that? Or are we circling?
Okay, thank you. Thank you. Please, hey, everybody pay attention.
Circling the wrong.
Which one are we circling? Okay, if you circle this one after your check, guess what? You're telling me that the question equals the answer. Thank you very much. That's not what I'm looking for. We're factoring this puppy. So this is what you're circling. This is your check. Don't circle your check. Okay? What's the solution to the problem? Here's the problem. That's my answer. No. Okay. All right. Is this getting easier? Let's see. Oh.
No, what is
Oh. Tantalizingly terrifying. Oh, this is terrible. Nightmare! This is nightmare now.
Wait, so what is 3?
Be afraid. Be very afraid.
Torture, because he gave me like 50 questions to do every day, and then he comes back from work and he's like, have you done them all? And if I didn't do them all,
Okay.
remember this was in America, so like,
Okay. Okay. Hi. Write this down. Now. Shh. Okay, quiet down now. Thank you. Looking up here. Now, do you guys remember when we expanded binomials where the numbers were first and the variables were second? That's okay. You could still do the FOIL method when the numbers are first. Guess what? The numbers are going to be first in our factored version. So this is just a bit of a rearrangement. So I'm going to write my brackets. Now, the easy part is over here. D squared. Guess what? D and D. Now, there's actually two options. I don't know if this is going to be minus D and minus D to give me a plus D, or if it's going to be plus and plus. I don't actually know yet. I got to check with these other parts too. So these numbers right here, I know have to multiply to negative 24. Negative 24. And I have to get to a negative 5, so let's keep that in mind. Is there any way that this can happen? Let's see, negative 24, well, there's 2 and 12, which there's no combination that gets me to 5, 2 and 12, right? There's 1 and 24, no combination gets me to 5 if I add 1 and 24, negative and whatever. But 8 and 3. Now 8 and 3. If one of these had to be negative, looking at this middle term, which one would you think should be negative?
A, negative 3. Negative 8.
Okay, if it was negative 3, I would have positive 8 minus 3 would give me positive 5. So it's going to have to be this one. Okay, well this helps. I'm going to put a negative 8 here and a positive 3 here, and then I can keep my pluses for my D because I've got the signs, the negative signs all taken care of here. So you can leave those as pluses. Okay, that's tricky. That one's a little tricky. I'll give you that. Now, let's do a FOIL to check and see if this is correct though. Check. What is negative 8 times 3? Negative 24. What is negative 8 times positive D? That's negative 8D. What's positive D times 3? Positive 3D. What's D times D? Positive D squared. Negative 24 minus 5D plus D squared. Is that what I started off with? Yes. It absolutely is. So guess what, guys? This is perfectly acceptable for your answer. Now, can I just shake up your world just a small amount? Are you ready for this? Some of you will be ready for this. Watch this. Watch this. This, actually, I'm going to do both of them.
Are we allowed to do that?
This is also okay,
Oh, okay.
right? Because remember, it doesn't matter which order I tell you the information, like, hey, dude, you owe me $8, but I have a donkey here. Or if I tell you, dude, I have a donkey, you owe me $8. Like, it doesn't matter which way I tell you that, as long as it's right? So you owe me $8, but I have a donkey. It's good news. Or, dude, I have a donkey, and you owe me $8. Those are the same. Because, you know why? Because we could rearrange this too if we really wanted to. So both these would be right. I could write this as d squared minus 5d minus 24. So this is the one probably that you would leave right now. That would be your answer. Okay? But both are fine. Hi, question. Why is what plus d?
No, it cannot be negative d.
Yeah, it can't be negative d.
Because then you're multiplying the negative d.
Okay, whoa. Okay.
Negative and
Okay.
negative.
Question which I'm going to spend just a half second on. Listen. Could this be negative d and negative d too? Yes, but then these signs would have to change as well. Because the negative would mess up. Like this negative 8 plus times a negative d would be positive 8 now, and we don't want positive 8d. So if you change these signs to both be negative, you would also have to change these signs to be the opposite of what they are. Which, again, we don't need to go there. Okay? Okay. Okay. There is much more to learn, but I'm going to give you your assignment here, and I'm going to let you get started here.
Math, I love math now, guys.
Oh, this is calculus. Let's see. Let's get out of calculus. Hey, MrMathWell.com is your friend for everything math. What are we? Chapter what? 3?
You know how much I love math now? But you understand?
Yes!
You guys were so smart doing the triangles, like so bad. Now I'm gonna do this.
Okay, grade 10s, listen up. We are very close to the end of class here. I want you to get as much of this done tonight as you can. I'm going to be continuing on section 3.6 tomorrow, but there's a couple examples from 3.5 that I will go over with you. The other thing I would mention, I was going to make that bigger, but I won't. I was going to mention the other thing, the example I did not get to today was that if you have a trinomial that has a greatest common factor in there, you have to pull that out first and then do this factoring. So that's the one example you may get to at the very end. If there's a greatest common factor, you should pull that common factor out first. Okay.